Okay, so chapter 5.4 is of conic sections, is equations of parabolas. So we've been talking about parabolas a lot, but now we're going to talk about parabolas that not only face up or down, but also can face left or right, which you can see down here. And we're going to go more in depth with the formula. So the definition of a conic section parabola is the set of all points in a plane that are equidistant from a fixed point and a fixed line. In other words, this point right here is the same distance to the focus as it is to the directrix. So let's talk about the formula. So the formula, if it's an up or down facing parabola, is going to start with some y minus the k. So that's the shift up or down for the vertex, equals 1 over 4 times p, and we're going to talk about what p is in just a minute, times x minus h squared. So it's pretty similar to what you're seeing, okay? So this 1 over 4p is the same thing as your a, or your negative a. So here our vertex is the point hk, so that's where we move the vertex to. Okay, then we have our directrix and our focus. I don't ever use these formulas, but you can memorize them. I'm going to show you how I do this when we start working the problems. But the directrix is this line right here. And it's always p distance behind the parabola. And the focus is always p distance inside of the parabola. Okay, so this is a point. So the directrix is a line, okay, and the focus is a point. Our axis of symmetry is a line, and it's this dashed line right here. It always cuts the parabola in the middle, so it's a mirror image on both sides. Okay, so that's our axis of symmetry. So when we're talking about a parabola that opens left or right, it's going to be the very similar formula, except now you'll notice that the x minus h is here and the y minus k is there. So those two things just swap places. The vertex is still the point hk. The directrix and the focus are still p distance. So this is the focus. It's the point that's p distance inside of the parabola. And the directrix is p distance behind the parabola. And then your axis of symmetry in this case is a y equals. So when we were looking here, it was an x equals because it was a vertical line. Okay. But now for this parabola, it's a y equals because it's a horizontal line. So the bigger the p value, the wider the parabola. Because remember, this is your a value or your negative a. And we have that pattern for parabolas, 1a over 1, 3a over 1, 5a over 1, 7a over 1. So the bigger this p value, the bigger this denominator is going to be. And the distance between the directrix and the focus is 2p. Because remember, so this distance here is p and this distance here is p to the vertex. So the total distance is 2p. All right, so let's look at actually doing some of these equations. All right, so we have the equation x minus 2 equals 1 over negative 16 times y plus 5 squared. So the first thing is our vertex. So this is my x and this is my y. So it's going to be 2, negative 5. So I can go 2, negative 5. Now I need to find my p value. So what I'm always going to do is I'm going to take whatever's right there and I'm going to set it equal to 1 over 4p because in my equation, that's what actually goes there. Now we can cross multiply to solve. So 4p equals negative 16. And the reason I say to do it this way is because if this is a whole number, then your p is going to have to be a fraction, which gets a little harder to solve. So if you just get in the habit of doing it this way, then you never have any problems. So now we get p equals negative 4. All right, so since p is negative and this x is here, that means it either opens left or right. since P is negative, that means it has to open in the negative direction, so to the left. So just like when you have your A value, right? If A is negative, it means it opens down. That's negative, right? So in this case, if it was an up and down opening one and A was negative, it would open down, but since it's left and right, it opens towards the negative direction because it's a negative A. So that means it opens left. Okay, and if our P is 4, I know that my focus is 4 inside my parabola and my directrix is 4 behind my parabola. So I know my parabola opens something like that. And I have that, I guess I can just draw it, that directrix right there. So now I can go on ahead and I can write my equation for my directrix, which is x equals 6, the equation of the line. My focus is a point, so that's going to be the point -2, -5, and my axis of symmetry goes right there. So that's y equals -5. All right, so let's take a look at the next one. So this one, the y comes first, so it's going to either open up or down. So I know it's going to open up or down. My vertex is going to be +2, -3. My p-value, I'm going to set that 1/8 equal to 1/4p, and I'm going to cross multiply to solve. So 4p times 1 is 4p, 8 times 1 is 8, divide by 4, and I get p equals 2. Okay, so since it's a positive, so p is positive, so that means it has to open up in this case. Okay, and this one right here is more like the ones we're used to seeing. And so I'm going to go on ahead and plot 2, -3. And we know it opens up with a p of 2. So that's going to be my focus. And my directrix is 2 behind it on this line. So my directrix is y equals -5. My focus is 2, -1. And my axis of symmetry is not y equals, because it's a vertical line right here. So it's x equals 2. Okay, so now let's take a look at how we can write the equation of a parabola, okay, in standard form, which is the form we've just been using. Okay, so I know my vertex is at 0, 0, and you'll see that I always do a little sketch. Okay, so my vertex is at 0, 0, and my focus is at 2, 0. So I know my parabola is going to open this way, and I know my p-value has to be 2, because that focus from here to here is a distance of 2. Okay, so p equals 2. Okay, so it's opening right, so it's going to be x. There's no shift, so there's no plus or minus there. Equals 1/4 times p, which is 2. So 1/8 y squared, because there's no shift. And that's it for that one. So let's go on ahead and take a look at the next one. I forgot a parenthesis right there. All right, so once again, I'm going to draw a little sketch here. So my vertex is at 3, -2. My focus is at 3, +1. Okay? So in that case, this is my p-value, and my parabola is going to open up like that. Okay? So to get from -2 to +1, I had to add 3. So my p is going to be 3. So now I'm going to go on ahead. I've got all the information I need. So I've got my vertex. This thing opens up or down. So it's going to start with a y. So y plus 2, because it's minus -2, equals 1/4 times p, which is 3. And then x minus 3 squared. And we're done. Okay, let's go ahead and take a look at the next one here. So the next one says my vertex is 0, 0. So once again, like I said, I always sketch these. And my directrix is x equals +3. So there's my directrix. So my p-value is 3. And this thing is going to have to open away from my directrix, so it opens to the left. So really, my p-value then has to be -3. All right, so now we're ready to put this in. So it opens left or right, so it's an x. My vertex hasn't shifted. Equals 1/4 times -3, which is -12. And then we have that y squared. All right, this next one here, my vertex is at -1, +4. And my directrix is at y equals 6. Okay, so that's up above there. So that means that this thing opens this way. And if this is y equals 4 and this is y equals 6, my p-value is 2, but since it's opening down, it's a -2. So remember, it always opens away from that directrix. So now I can plug this in. It opens down, which means it's going to be a y. So that's y -4 equals 1/4 times -2, which is -8. And then we have x plus 1 squared. All right, so now we're getting one that has the focus and the directrix. We have to find the vertex in this case. So let's go ahead and sketch this thing. So we have a focus at 3, 0, and we have a directrix at x equals -3. Okay, so on our x-axis, that's what this looks like. So we know this thing opens to the right because it's opening away from our directrix and towards our focus. Remember that this distance here is 2p. So 2p equals -3 and 3. Okay? The distance from here to here is 6. So we know that our p has to equal 3, and we know that it's going to be positive because of the direction the parabola is opening. Okay? And if it was a little bit off and you were having to count, okay, so our p is 3. So now we're just going to go on ahead. We have to find our vertex. Our vertex is smack in the middle of that. So our vertex in this case is 0, 0. So now we're going to go on ahead and say x equals 1/12 y squared. Take a look at this next one. Okay, so our focus is at -1, +4, and our directrix is at y equals -2. Okay, so it's down here. So this is -2 and this is +4. So that p-value, 4 minus -2 is 6. So p is 6. Yeah. And our 2p is 6, sorry, so p is 3. Remember that this thing always opens towards our focus. So we know it's opening up, but we need to figure out where our vertex is. Well, if p is 3, the distance from here to our vertex is 3, which makes this a 1. So our x value is going to be -1, and our y value then is going to be +1. So now we can go on ahead and write the equation for this. So it's going to be y -1 equals 1/12 x plus 1 squared. Okay, so the next one says complete the square to write the equation in this standard form. Okay, so remember, to complete the square, we've already got the constant over here. So we're going to add a blank and a line, and we have to do the same thing here. So we're going to add a blank and a line. All right. So now to get what goes in there, we take this b value here. Trying to draw an arrow, it's not working. So we take it, we divide by 2, and we square that number. And that's what goes in both of those spots. Okay, so now we have y -7 plus 4 equals x squared plus 4x plus 4. Okay, so now we have y -3 equals this one right here. We can factor. In this case, there's not going to be an a value because when we factor this, it's x plus 2 times x plus 2 or x plus 2 squared. So our a value is just 1 in this case. Okay, so that 1 over 4p is just 1. Okay, and remember, if you want the shortcut and you don't want to factor this, whatever number is there when you divide is always what's going to be in those parentheses. Okay, and that's it. Okay. So now it says, hey, what is the value of p in our equation? Okay, now this is where I warned you about making sure you set this up right. So this value here is 1. So we need to say 1 over 1 equals 1 over 4p. We're going to cross multiply. So 4p equals 1. Divide both sides by 4, and we get p equals 1/4. Okay. Our vertex is going to be at -2, +3. And this parabola, that's a y. So it opens up or down. This value and the p value is positive. So it opens up. And I believe, let me double check, but I think that is it for 5.4. Oh, nope, there's one more little thing in 5.4. All right, so 5.4, this tells you how you can tell if things are a parabola, a hyperbola, an ellipse, or a circle. So the very first thing you should check for is to see if there is only one squared term. If there's only one squared term, it has to be a parabola. If not, then you're going to move on to step 2. So step 2 says check the signs, because if the signs are different, it's a hyperbola. Otherwise, it's going to be either an ellipse, okay, or a circle. Okay, so then we're going to check for any terms that include both x and y, like a 2xy. If it has both terms, it's an ellipse. Otherwise, we need to keep looking. If the squared terms have different coefficients, then it's an ellipse. Otherwise, it's a circle. So what's going to happen here is a lot of times you're going to see something like this. Okay, so you're going to see a function like this. Okay, so you're going to have to check through it. Oh, it's got 2 squared terms. So I know it's not a parabola. So now we need to see if it's a hyperbola. Oh, these 2 signs are the same. So those 2 signs are the same. So we know it's not a hyperbola. So we need to go on. It does not have any xy terms. So we need to go on. Now we say, oh, those coefficients are different. So this would be an ellipse. Okay, without having to solve it and putting it into standard form. All right, I'll see you guys next time. Have a great evening.